Let's talk about electricity. You think you know what it is, don't you? I mean, you use it constantly. Right now, electrons are flowing through the device you're reading this on. Electricity is powering the lights around you, keeping your food cold, charging your devices. It's everywhere. So it feels obvious that you must understand it. All right then, explain it. What actually happens when you plug something in? Where does that power come from? What is electricity at its core? Most people answer with something vague. They say it's energy. They say it's electrons moving. They say it's current in a wire. But those answers don't really explain anything. They just rename the mystery. Yes, electrons are moving, but why are they moving? What's pushing them? And why does that pushing create light, heat, or motion? The truth is far stranger than we usually admit. Electricity is deeply weird, profoundly weird, and the way we teach it hides that weirdness. We present it as normal, predictable, safe, almost mechanical. But when you actually look at what's happening underneath, you realize we're manipulating something extraordinary, something that forces you to rethink how reality works. Let me show you. Try a simple experiment. Take a strip of plastic wrap, rip it off the roll. Now rub it quickly between your hands like you're trying to warm them up. Then hold it near the back of your hand without touching. Watch what happens. The hairs on your arms start to move. They stand up. They lean toward the plastic. You can feel the plastic pulling on you across empty space. Stop and think about that. You rubbed plastic, that's all. No batteries, no wires, no generator, just friction. And now that plastic can reach across air and tug on your body. How? In normal experience, forces require contact. You push a chair, you touch it. You lift a book, you touch it. Contact seems necessary, except here's plastic not touching you, pulling on you anyway. Most people shrug. Static electricity, a classroom curiosity. But what you're looking at is one of the four fundamental forces of the universe, the electromagnetic force, acting across distance, the same force holding every atom in your body together. And we treat it like a parlor trick. When you rubbed that plastic, you scraped electrons off your skin and piled them onto the plastic. Maybe one extra electron for every trillion atoms. That sounds insignificant. But here's the part that breaks intuition. Those extra electrons repel each other with unimaginable strength. Take two electrons 1 centimeter apart. The electromagnetic force between them is about 1042 times stronger than gravity between them, a 1 followed by 42 zeros. At the scale of electrons, gravity is irrelevant. Electromagnetism dominates everything. So why doesn't matter explode? If those forces are so strong, why isn't everything tearing itself apart? Because of cancellation. Inside atoms, you have positive protons and negative electrons. Opposites attract, likes repel, and the magnitudes are equal. So in ordinary matter, positive and negative charges are mixed together in near-perfect balance. Every proton is surrounded by electrons. Every electron is surrounded by protons. The enormous repulsions cancel the enormous attractions. The forces are still there, unimaginably strong, but balanced so precisely that the net effect is neutral. And because those forces are so huge, even the tiniest imbalance produces noticeable effects. When you charge the plastic, you disrupted the balance by a microscopic fraction. And that was enough to move the hairs on your arm. Now pick up a mug. What are you feeling? You think you're feeling solid ceramic, physical contact between your hand and the mug. But you're not. You're feeling electromagnetic repulsion. The electrons in your hand are pushing away from the electrons in the mug. That repulsion prevents the atoms from overlapping. Your hand never truly touches the mug. There's always a tiny gap maintained by electromagnetic force. What you interpret as solidity is force interaction. You've never actually touched anything. Every push, every sensation of pressure, every resistance you've ever felt has been electrons repelling electrons across microscopic distances. Now think about what that means. All the mechanical forces you experience, pushing doors, sitting on chairs, walking on floors, they're all electromagnetic in origin. When you push a door, electrons in your hand repel electrons in the door. When you stand on the ground, electromagnetic repulsion holds you up. Even light, what you see, is electromagnetic waves interacting with electrons in your eyes. Your entire sensory world is electromagnetic interactions. Now let's talk about wires. Imagine a copper wire running from an outlet to a lamp. You flip the switch. The lamp lights instantly. The usual explanation says electricity flows like water, electrons entering one end and traveling to the other. But that picture is misleading. Electrons in a wire move extremely slowly, at millimeters per second. At that speed, it would take minutes for one electron to cross a room, yet the light turns on immediately. So what's happening? The wire is already full of electrons. Copper contains free electrons ready to move. When you close the switch, you create a voltage difference, an electric push. That push acts on electrons at one end. Because electrons repel each other, that force transmits to neighboring electrons which push the next ones and so on. It's like a tightly packed line of people. Push the first person, and the last one feels it almost instantly. Not because anyone ran down the line, but because the force transmitted through the crowd. The electromagnetic signal travels near the speed of light. That's why electricity can deliver energy across huge distances almost instantly. But where does the push originate? Trace the circuit backward. Your lamp connects to an outlet. The outlet connects to wiring in your walls. Those wires connect to power lines stretching across cities. Eventually, those lines lead to a power plant, maybe miles away. Inside that plant, something massive is spinning, a turbine weighing tons, rotating at enormous speed. That spinning motion is what ultimately powers your lamp. How can motion in one place affect electrons miles away? Because electricity and magnetism are unified. They're not separate phenomena. They're two aspects of the same fundamental force, electromagnetism. Moving electric charges create magnetic fields. Changing magnetic fields create electric currents. They're inseparable. That unity is what allows generators to exist, machines that turn motion into electricity. And that's where the story gets even stranger. Electricity and magnetism are not separate forces that occasionally cooperate. They are different faces of the same underlying phenomenon, the electromagnetic force. You can't truly have one without the other. Wherever electric charges move, magnetism appears. Wherever magnetic fields change, electric charges respond. This isn't metaphorical, it's literal physics. To see how deep this connection goes, imagine a generator, the machine at the heart of almost every power plant on Earth. At its simplest, a generator is just copper wire and a magnetic field. That's it. No mystery components, no hidden energy source, just metal and magnetism interacting through motion. You take coils of copper wire and spin them inside a magnetic field. As the wire moves through that field, something remarkable happens. The magnetic field pushes on the electrons in the copper. It exerts a force on them, not by contact, but through the electromagnetic field permeating space. The electrons resist at first. They don't want to move, but the field keeps pushing. And as the wire continues spinning, the push becomes continuous. Electrons begin to flow. That flow is electric current. So electricity, in this context, is simply electrons being forced to move by motion through a magnetic field. Mechanical motion becomes electrical energy. Now reverse the process. Instead of spinning wire to create electricity, you send electricity through wire placed inside a magnetic field. Now the moving electrons feel forces from the magnetic field. Those forces push on the wire itself. The wire moves. That's a motor. Same ingredients, same force, just reversed cause and effect. Generators turn motion into electricity. Motors turn electricity into motion. Both rely on the unity of electricity and magnetism. This symmetry should feel almost unsettling. You're telling me I can spin metal in one place, and metal moves somewhere else, connected only by thin wire? Yes. You're telling me falling water or steam pressure can rotate turbines which push electrons, which push other electrons across entire regions, which make machines move miles away? Yes, and we do this constantly. Every power grid on Earth operates on this principle. Hydroelectric dams, coal plants, nuclear plants, wind turbines. All they really do is spin generators. Waterfalls, turbines rotate. Copper coils spin in magnetic fields. Electrons get pushed. That push travels outward through transmission lines at near light speed, reaching homes, factories, cities. The electrons in your house begin to drift in response, transferring energy into devices, motors, heaters, lights, processes. Motion in one location becomes motion, light, and heat somewhere else, not through gears or belts or rods, but through electromagnetic fields acting across space. And it doesn't even require physical contact between circuits. Take two coils of copper wire. Place them near each other, but don't connect them. Run electricity through the first coil. As electrons flow, they create a magnetic field around the wire. That field expands outward into the surrounding space. If the current changes, increasing, decreasing, alternating, the magnetic field changes too. Now that changing field reaches the second coil, it pushes on the electrons there, forcing them to move. Current appears in the second coil, even though no wire connects them. That's electromagnetic induction. That's a transformer, the backbone of the power grid. Energy transfers from one circuit to another through changing magnetic fields alone. Metal influencing metal across empty space. No contact required. This is how power plants step voltages up for long-distance transmission and step them back down for safe household use. Gigawatts of power moving through networks guided by fields that fill space invisibly. Just copper and motion. That's all it takes. When you really see what's happening, the everyday becomes surreal. You realize that what we call mechanical forces, pushing, pulling, pressure, are not fundamental at all. They're consequences, derived effects. When you push a door, you're not exerting some independent mechanical force. You're creating electromagnetic repulsion between electrons in your hand and electrons in the door. When you sit in a chair, electromagnetic forces prevent your atoms from passing through the atoms of the chair. When you walk, electromagnetic repulsion between your feet and the ground holds you up against gravity. Even friction, the resistance you feel when sliding surfaces, arises from electromagnetic interactions between irregular atomic structures. All the solidity you perceive, all the resistance, all the pressure, electromagnetism. It's the mediator of your physical experience. And light itself, the thing that allows you to see, is electromagnetic radiation, oscillating electric and magnetic fields propagating through space. When light hits your retina, those oscillating fields push electrons in photoreceptor molecules. That electron motion triggers chemical reactions. Signals travel along neurons. Your brain interprets the pattern as sight. So vision is electromagnetic interaction. Heat, that's atoms vibrating due to electromagnetic forces binding them together. Chemistry, that's electrons interacting through electromagnetic attraction and repulsion to form molecular bonds. Biology, that's chemistry organized into living systems, still electromagnetic at its core. Your nervous system runs on electrical signals. Your muscles contract through electrochemical gradients. Your thoughts correspond to patterns of electromagnetic activity in neural networks. Your body is an electromagnetic machine. Everything you feel, see, and physically interact with arises from this one force. And here's the part that unsettles physicists and philosophers alike. You can't explain the electromagnetic force in terms of anything simpler. You can explain springs using electromagnetic bonding between atoms. You can explain pressure using electron repulsion. You can explain elasticity, friction, chemical bonds, all electromagnetically. But when you ask, why does the electromagnetic force exist? There's no deeper mechanical analogy. It's fundamental, one of the four base interactions in nature, alongside gravity, the strong nuclear force, and the weak nuclear force. You reach bedrock. You can describe it mathematically. You can predict it with extraordinary precision, but you can't reduce it to something more intuitive. It just is, and it acts across distance. That idea, action at a distance, once deeply troubled scientists. It felt mystical. How could objects influence each other without touching? The answer that emerged reshaped physics entirely. Fields. Space isn't empty. It's filled with electromagnetic fields extending everywhere. Charged particles interact through those fields. An electron creates an electric field around it. Another charge entering that field feels a force. No contact required. The field mediates the interaction. When charges move, the fields change. Changing fields propagate as waves, electromagnetic waves, at the speed of light. Light itself is a ripple in the electromagnetic field. So when you flip a switch, you're not sending electrons racing across the grid. You're launching a change in the electromagnetic field that propagates through the circuit. The electrons respond locally, drifting slowly, but the field change travels fast. That's why energy delivery is rapid, even though electron drift is slow. Now step back and absorb what this means. The world that feels solid, mechanical, contact-based, that's not the underlying reality. The deeper layer is fields interacting with particles across space. Solidity is an emergent effect. Touch is electromagnetic resistance. Motion transfer is field interaction. When you close a circuit, electrons everywhere in that circuit begin adjusting to a new electromagnetic configuration. At the power plant, turbines spin. Magnetic fields rotate. Electrons get pushed. That push propagates outward as a field change. It reaches transmission lines, transformers, local wiring, and finally your home. Electrons in the filament of a bulb begin to move through a narrow resistive path. They collide with atoms in the filament, transferring energy. The filament heats. Heat rises until the filament glows white hot. Glowing matter emits electromagnetic radiation, visible light among it. Those photons travel outward at light speed. Some reach your eyes. Electromagnetic waves move electrons in your retina. Chemical cascades begin. Neural signals propagate to your brain. You perceive light, from spinning turbines to neural perception. Every stage electromagnetic, every conversion, every transfer, every sensation. It's one continuous chain of electromagnetic interactions spanning miles, machines, and biology. And the more you follow that chain, the more surreal it becomes. Because you realize that what we call electricity isn't a substance flowing like water. It's the manipulation of fields and charges, and the structured interactions of a fundamental force. We're not channeling a fluid, we're orchestrating electromagnetic dynamics, and that realization reframes everything. When you really sit with that realization, it begins to alter how you see everything around you, because electricity stops being a utility, a service delivered through wires, and starts looking more like a window into the operating system of reality itself. Think about what we've established so far. Forces you interpret as touch are electromagnetic repulsions. Motion can be converted into electric current through magnetic interaction. Electric current can become motion again. Energy can transfer across distance through changing fields without direct contact. Now extend that outward. The same electromagnetic principles operating in a power plant are operating inside your body right now. Your nervous system runs on voltage differences across cell membranes. Neurons maintain ion gradients, imbalances of charge. When a neuron fires, channels open, ions flow, voltage shifts propagate along the cell. That signal jumps synapses through electrochemical release. Networks activate, muscles receive electrical instructions and contract. Your thoughts, decisions, memories all correlate to electrical patterns in neural tissue. You are not just using electricity, you are electricity organized into self-awareness. And that should reframe the scale of what we're discussing, because when you flip a switch, you're not just activating an external force, you're interfacing one electromagnetic system, the grid, with another, your technology, both governed by the same underlying physics that governs your biology. There's continuity between the electricity and power lines and the electricity in your nervous system. Different scales, different structures, same force. Now consider resistance. When electrons move through a conductor like copper, they drift relatively easily. Copper atoms form a lattice that allows many electrons to move freely, but not all materials allow this. In some substances, electrons are tightly bound to atoms. Trying to push current through them is difficult. The electrons collide frequently, transferring energy to the atomic lattice. That transferred energy manifests as heat, so resistance is essentially electromagnetic friction, electrons interacting with atomic structures in ways that impede flow. In a light bulb filament, resistance is extreme by design. Electrons forced through the thin tungsten wire collide constantly. Energy transfers into the lattice. Temperature rises dramatically. At around 2500–3000 degrees C, tungsten glows white hot. The light you see is thermal radiation, electromagnetic waves emitted because charged particles are accelerating within hot matter. So, light from an incandescent bulb is electromagnetic radiation generated by electromagnetic resistance heating. It's electromagnetism producing electromagnetism. In more efficient lighting, LEDs for example, electrons don't heat a filament. Instead, they drop between energy states in semiconductor materials, releasing photons directly. Different mechanism, same force at the core. Now zoom out again, far beyond homes and cities. Stars shine through electromagnetic processes too. Inside stars, nuclear fusion releases energy. That energy excites charged particles in plasma states. Accelerating charges emit electromagnetic radiation, light, X-rays, gamma rays. The sunlight reaching Earth is electromagnetic radiation generated by charged particle interactions in stellar plasma. Your entire energy economy ultimately traces back to electromagnetism driven by nuclear processes in the sun, or in ancient stars whose energy was stored in fossil fuels. So when you turn on a lamp, you're participating in a cosmic electromagnetic chain that began in stellar furnaces. And yet, despite how universal electromagnetism is, it doesn't dominate everything. Gravity shapes galaxies. The strong nuclear force binds atomic nuclei. The weak force governs radioactive decay. But electromagnetism is the force that structures matter at human scales: chemistry, materials, biology, technology. It's the force that makes complexity possible. Without electromagnetic bonding, atoms wouldn't form molecules. Without molecules, no chemistry. Without chemistry, no life. So electricity isn't just a technological tool, it's an expression of the force that allows structured matter to exist at all. Now think back to the earlier idea, action at a distance. Historically, this idea felt almost supernatural. Newton himself was uneasy about gravity acting across empty space, but electromagnetism made action at a distance undeniable, measurable, manipulable. Faraday introduced the concept of fields to explain it. Maxwell unified electricity and magnetism mathematically, showing that changing electric fields create magnetic fields and vice versa. His equations predicted electromagnetic waves traveling at a finite speed, the speed of light. That's when the realization hit. Light is electromagnetic. Radio waves, microwaves, infrared, ultraviolet, X-rays, all the same phenomenon at different frequencies. Your Wi-Fi signal, your phone connection, broadcast radio, medical imaging, all electromagnetic waves. So the same force making arm hairs rise near charged plastic also carries global communications through space. We manipulate electromagnetic fields to encode information, transmit it across continents, and decode it instantly. Civilization runs on structured electromagnetic signaling, and inside computers the scale shrinks even further. Billions of transistors switch on and off, controlling electron flow through semiconductor channels. Voltage differences represent binary states. Patterns of charge become logic operations. Logic operations become software. Software becomes communication, art, science, finance, culture. Information itself becomes electromagnetic patterning. So when you send a message, stream a video, or run a program, you're orchestrating electron motion across microscopic circuits at staggering speeds. Electricity isn't just powering devices. It's processing meaning. Now consider the philosophical weight of that. Human thought, electromagnetic activity in neural tissue, builds machines that manipulate electromagnetic activity in silicon to store and transmit human thought. It's electromagnetism reflecting on itself through consciousness and technology. And yet, despite how advanced our manipulation is, the underlying force remains fundamentally mysterious. Quantum electrodynamics, the quantum theory of electromagnetism, describes interactions as exchanges of virtual photons, force carriers mediating electromagnetic effects. Charges interact by emitting and absorbing these quanta within electromagnetic fields. The math predicts outcomes with extreme precision, among the most accurate predictions in all science, but conceptually it deepens the strangeness. Forces mediated by particle exchanges in probabilistic quantum fields. Reality at its base isn't mechanical. It's relational, field-based, quantized. So electricity, when fully understood, becomes a gateway concept, a bridge between classical intuition and quantum reality. It starts with rubbing plastic and ends with quantum field theory, and that journey reshapes how you interpret everyday experience. Because once you see that all contact is electromagnetic, that motion can become current, that fields carry influence across space, that light is field oscillation, that biology runs on charge gradients. You stop seeing electricity as a convenience. You start seeing it as infrastructure woven into the fabric of existence. When you flip a switch, you're not summoning a resource. You're reconfiguring electromagnetic relationships across a vast network. You're altering field conditions, extending from generators to grids to circuits to filaments to photons to neurons. A single action cascading through layers of electromagnetic interaction until perception arises in your mind. That's the scale hidden behind familiarity. And we've built an entire civilization on the ability to harness it reliably. Power grids spanning continents, communication networks encircling the planet, computational systems processing unimaginable volumes of information, all rooted in the same force that makes plastic cling to your skin. That continuity, from static cling to global infrastructure, is what makes electricity so conceptually profound. It's not just useful, it's foundational. And we're not finished uncovering its depths, because the deeper physics goes, the stranger electromagnetism becomes. As physics pushed deeper into electromagnetism, the picture became even less intuitive and far more profound. At first, electricity seemed like something you could treat mechanically. Charges, wires, currents, things you could visualize like fluids moving through pipes. That analogy worked well enough to build early technology. Telegraphs, motors, generators, all engineered using classical electromagnetic theory. But when scientists began probing smaller scales, atomic and subatomic, the classical picture started to fracture. Electrons didn't behave like tiny billiard balls flowing through conductors. They behaved like quantum objects, entities with wave-like properties, existing in probability distributions rather than precise locations. In conductors, electrons don't simply stream in neat lines, they occupy energy states, forming what's called an electron sea, a collective quantum system. When voltage is applied, you're not just pushing individual particles, you're altering energy distributions across that system. Current becomes a statistical drift of many quantum entities responding to an imposed field, and resistance, that isn't just collisions in a mechanical sense. It's quantum scattering, electrons interacting with lattice vibrations, phonons, impurities, and other quantum effects. So even the simple act of electricity flowing through a wire is underpinned by quantum field interactions too complex to visualize directly. Then there's superconductivity, where resistance drops to zero. Cool certain materials to extremely low temperatures, and electrons pair up into Cooper pairs, forming a coherent quantum state. In that state, they move through the lattice without scattering, no resistance, no energy loss. Current can flow indefinitely. That phenomenon reveals that electricity isn't just particle motion. It's collective quantum behavior emerging under specific conditions. Magnetism, too, deepens in strangeness at quantum scales. Permanent magnets arise from electron spin alignment. Intrinsic quantum angular momentum, not literal spinning, but a fundamental property of particles. When many spins align, their magnetic moments add, producing macroscopic magnetic fields. So the magnets used in generators, the devices powering civilization, ultimately derive their strength from quantum spin interactions at atomic scales. Motion in a power plant couples to magnetism, rooted in quantum spin, which couples to electron drift in conductors, which transmits energy through fields to devices that convert it into heat, light, or motion. Every level layered atop deeper physical principles. And yet the macroscopic world smooths this complexity into reliability. You flip a switch and the light turns on every time. The predictability hides the underlying strangeness, but occasionally the deeper reality surfaces. Consider electromagnetic waves traveling through empty space, no medium, no substance, just oscillating electric and magnetic fields sustaining each other as they propagate. An accelerating charge disturbs the electromagnetic field. That disturbance moves outward at light speed, self-propagating, self-sustaining. That wave can travel across millions of kilometers, encounter matter and transfer energy to electrons. That's sunlight warming your skin. That's radio signals reaching antennas. That's cosmic radiation crossing interstellar space. Electromagnetic influence doesn't require matter. Fields alone carry energy and momentum. So when you think about electricity extending across power grids, remember, the same force extends across the universe. Pulsars emit electromagnetic beams sweeping across space. Galaxies radiate electromagnetic signatures. The cosmic microwave background is relic electromagnetic radiation from the early universe. Electromagnetism isn't local technology. It's a universal language. Now return to Earth, to infrastructure. Power transmission over long distances requires high voltages. Why? Because energy loss in wires is proportional to current squared times resistance. So engineers step voltage up using transformers, electromagnetic induction again, allowing the same power to travel with lower current and reduced losses. At substations near cities, transformers step voltage down to safer levels for distribution. All of this happens through changing magnetic fields, coupling circuits without direct electrical contact, entire regions powered through synchronized electromagnetic systems operating in phase across vast networks. Grid stability itself becomes an electromagnetic coordination problem. Frequency regulation, load balancing, reactive power control. If generators fall out of phase, instability cascades. So maintaining electricity supply requires not just generating current, but harmonizing electromagnetic oscillations across infrastructure. Civilization literally depends on synchronized electromagnetic rhythm. Then there's storage. Batteries don't store electricity directly. They store chemical potential created through electromagnetic forces, binding ions and electrons in different configurations. When connected to a circuit, chemical reactions release electrons, creating voltage differences that drive current. Again, chemistry. Electromagnetism. Capacitors store energy in electric fields between charged plates. Inductors store energy in magnetic fields created by current. Energy stored not as motion, but as field configuration. So devices across electronics manipulate electromagnetic fields to store, release, and regulate energy flow.